Hello students, welcome to Learner's Planet, Problem Solving Session 5 of Metals and Non-Metals. In this session, we will be discussing about the questions related to the processes of metallurgy. So let's start with our first question. Yeah, the very first question here is the name of Al2O3 2H2O. We know that this is an ore. Now what is the name of this ore? It is what? It is an ore of aluminium, and the name of this ore is bauxite. Now this you have to mug up. The names you have to mug up. Here there can be no logics. Bauxite, there is another ore of aluminium, that is Al2O3H2O. What is it? Or only Al2O3. This Al2O3 is corundum. Now you must have seen students, people wearing those gemstones, those precious gemstones. Somewhere ruby or sapphire, topaz. So these have got specific colors. These are all what? These are all aluminium oxides. These are their gamma crystals. And together with some transition element like chromium, or in somewhere there is titanium. So these particular elements impart such colors. So your gemstones are basically aluminium oxide, that is corundum. Al2O3H2O is diaspore. So these are ores of aluminium. Now in this case, the name of this ore CuCO3 CuOH twice is. Now is this the ore of carbon? No, because carbon is a non-metal. What is a metal here? It is copper. So what is the name of this ore? The name of this ore is malachite. What else are the ores of copper? It is Cu2S. That is, these are pyrites, right? Or this is copper sulfide. This is one of the ore. Pyrites is Cu2O. Copper 1 oxide is pyrites. This is copper glance with sulfur. So these are the ores of copper. The name of MgCO3 CaCO3 is. Now students, this is an ore of magnesium. This is not the ore of calcium. And its name is dolomite. Now this next ore is CuFeS2. This is also an ore of copper, and these are called as copper pyrites. The maximum impurity here is of Fes. Now these are some of the ores, and this is just an example. So try to remember at least the names of the ores which are given in your NCERT, or which I have discussed in the session. Now moving to the next question. After calcination, the ore becomes. What is calcination? Calcination is heating of ore in the absence of air. Okay? Heating of an ore in the absence of air. Now for what type of ores it is done? It is done for oxide ores like bauxite, or carbonate ores like calamine, ZnCO3, or other carbonate ores. Now what is done? It is heated. So what will happen? With bauxite, there are water molecules associated with it. So they will be removed. With zinc carbonate, carbon dioxide will be removed out, and this will make the ore porous. Okay, so after calcination, what happens? There are no chemical changes, but what happens? The ore becomes porous. There is no reaction as such. It gets heated and it gets dissociated, like ZnCO3. When it is heated, what will be the products formed? The products formed would be zinc oxide plus CO2 gas would be released. Now let's take up our next question. Carbonate and sulfide ores are usually converted into their dash during the process of extraction. So what is done? During extraction, these carbonate and sulfide ores are converted to their oxides. Why? Because reduction of oxides is easier than reduction of carbonates or sulfides. So these are converted to their respective oxides by either calcination or roasting. Now in this case, students, the third question, sulfide ores are converted into their oxides by. Now what is it? This is sulfide ore. What it will require? It will require a large amount of oxygen to be converted into its oxides. So it can obviously be not converted by calcination. It will be converted by roasting. That is, now what is roasting? Roasting is heating of an ore in the presence of air or in the presence of oxygen. Now let's move to our next question. What are the products obtained in the given reaction? That is copper 2 oxide with copper 2 sulfide. That is with Cu2O plus Cu2S. Now what is it? Is it 2 oxide? It is copper 1 oxide and copper 1 sulfide. Cuprous oxide and cuprous sulfide. So I should mention here it is 1. So it is copper 1 oxide and copper 1 sulfide. And the products obtained here would be, on heating, the products obtained would be Cu solid, 2Cu solid plus SO2 gas. So these will be the products. We discussed this while extraction, while this roasting of this copper oxide. Now what is our next question here? An ore which gives carbon dioxide on heating or on treating it with dilute acid is a dash ore. So it is releasing what? It is releasing carbon dioxide. So what type of ore it has to be? It is a carbonate ore. Now taking up our next question, here it is an ore which gives H2S or hydrogen sulfide gas on treatment with dilute acid is a dash ore. Now which will give sulfide? Obviously a sulfide ore. So this has to be a sulfide ore. I'll give you one example here. It is a sulfide ore. It can be either lead sulfide or zinc sulfide. So these sulfide ores, when they are treated with acids, they give out hydrogen sulfide. Now let's take up some difficult questions. This is also a simple one. Dash is a non-metal used to preserve food materials. Now, so in order to prevent rancidity, what is done is that the food materials are flushed with nitrogen gas. So which is a non-metal here? It is N2 gas. Why? Because this is inert. Why inert? Because there is triple bond between two nitrogen atoms. So this is inert. And it is not going to react with the what? With the food material. Now the next question is, dash is a non-metal used as fungicide. Fungicide, or it is also used for making gunpowder. So what is it? It is also used in medicines. It is sulfur. Sulfur drugs are used. It is used for making gunpowder as well as fungicide. Now what is our next question? Dash is a non-metal used for making electrodes of electrolytic cells and dry cells. Now just tell me, why when it is used as an electrode in a dry cell, it means it is conducting electricity. So which is an exceptional non-metal which is conducting electricity? It is carbon. In the form of what? In the form of graphite. So it is graphite. So it is an allotrope of carbon. Now let's take up our next question. N2O is a dash oxide. What is it? It is a neutral oxide. Or you can also write it as it is a covalent oxide. But here when such type of questions are asked, they mean that it is, you have to tell whether it is an acidic or basic or neutral or amphoteric. So N2O is a neutral oxide. Now let's move to some more questions. In the given reaction, that is 2NaCl plus Br2 gives 2NaBr plus Cl2. Chlorine is more reactive, so it is released out as chlorine gas. Is it? Because it is more reactive, it will be replaced from its salt solution. No. A more reactive metal displaces less reactive metal from its salt solution. So this option is wrong. Here bromine should be more reactive. Right? So this option is wrong. Now let's take up our next option. Bromine is more reactive, so it is displacing chlorine from its salt solution. Is bromine more reactive than chlorine? How we find out the reactivity of non-metals? We find out the reactivities from the group or the position in the group, position of non-metal in the group. Say I have got fluorine in this group, chlorine in this group, there is bromine and there is iodine. Now what happens to their reactivities? Their reactivities decrease down the group. So this is decreasing. So which is more reactive, chlorine or bromine? It is chlorine which is more reactive. So if chlorine is more reactive, then can chlorine be replaced by bromine? No. This reaction itself is wrong. So what will be your correct option? Given reaction equation is wrong. The reaction cannot take place. Why? Because bromine is less reactive than chlorine and bromine cannot displace chlorine from its salt solution. So the given reaction equation is wrong. Reaction cannot take place. Our next option is bromine is less reactive than chlorine and it cannot displace chlorine from its salt solution. So this is also correct. Okay. So what will be our answer? Our answer would be C and D. One more option should have been given here. So both C and D are correct. So when you are getting questions related to the reactivities of metals, you have to refer to reactivity series. Whereas when you are getting questions related to reactivity of non-metals, you have to refer to the positions in the groups. Our fifth topic would be periodic table and I'll be discussing that periodic table in details. Now let's move to our next question here. It is a matrix match type question. Copper solid plus sulfuric acid, aqueous. Now just tell me, will copper react with dilute sulfuric acid? Let's write the reactivity series of metals. How is it? Potassium at the top, then is sodium, then is what? Magnesium, then is calcium, then aluminium, some metals like zinc, iron in between, then is your hydrogen, then copper, then is your mercury, then is your silver, and finally it's the gold. Now, where is copper present? Copper is present below hydrogen in the reactivity series. So can it displace hydrogen ions from acids? What copper has to do to displace hydrogen ions? To displace hydrogen ions, what is to be done is that hydrogen ions should be given electrons. Now in this case, when it is given electron, then only it will form H2 gas. Now when this copper is present below hydrogen, can it give its electron to hydrogen? No. Here copper is less reactive than hydrogen. So what should be the answer of this first one? It should be D, no reaction. Now moving to the next, zinc solid with sulfuric acid. Again refer to the reactivity series. Now in this case, zinc is lying above hydrogen in the reactivity series. So what zinc can do? Zinc can lose 2 electrons, and what it can form is Zn2 plus ions and 2 electrons. Now these 2 electrons will be accepted by hydrogen ions, and it is going to form what? It will form hydrogen gas, that is H2 gas. So what would be the right option for this? The hydrogen gas is evolved. A. Now next reaction is 2NO2 plus H2O. Now NO2 is what, students? It is an acidic oxide, or it is a non-metallic oxide. So when it is dissolved in water, it should form acids. So are there acids in our options? Yes, that is HNO2 and HNO3. So what would be the option for this? B. And carbon plus oxygen, that oxygen here is, remember this point, this is insufficient. So as it is insufficient, it is going to form what? Carbon monoxide. And carbon monoxide is a neutral oxide. So what should be the option here? C. The product is a neutral oxide. Had it been sufficient oxygen or large amount of oxygen gas, then what would have been the product formed? The product formed would have been carbon dioxide, which is what? Which is an acidic oxide. So here the product I'll write as carbon dioxide, and it is an acidic oxide. So while solving questions, you need to remember whether the reactants are in dilute state or in concentrated state, or they are sufficient or insufficient, or small quantity or large quantity. Now let's take up the next question here. It is SnCl2 plus aluminium. Now this is what? SnCl2 is a salt, aluminium is a metal. Now what we did was that the more reactive metal displaces less reactive metal from its salt solution. Now in this case, tin and aluminium, to your reactivity series, which is more reactive, aluminium or tin? Aluminium. So aluminium can displace tin from its salt solution. So what would be the answer? It would be B. Now taking up the second one, that is AlCl3 plus zinc. Now in this case again, which is more reactive? Aluminium. Which is less reactive? Zinc. So can zinc replace aluminium or displace aluminium? No. So what should be the answer? It should be no reaction. Now in our third option, aluminium chloride plus calcium solid. In this case, which is more reactive, aluminium or calcium? Calcium. So calcium is going to displace aluminium from its salt solution. And what will be the product form? Aluminium solid and CaCl2. So the answer would be A. And mercury with sulfuric acid, what will happen? Now mercury is lying below hydrogen in the reactivity series. So mercury cannot reduce hydrogen ions. So what would be the answer? Hydrogen gas is not evolved. So this is the way how we solve questions. Let's take up the next problem. It is magnesium, the most reactive metal. Is it? No. Potassium is the most reactive metal. So this will go here. So fourth is A. Now second is copper. Copper, is it more reactive than bromine? There is no comparison because copper is a metal and bromine is a non-metal. So does not react with dilute acids. So it should be C here. Now our next is chlorine. Now there are chlorine and bromine. These both are non-metals. So chlorine is more reactive than bromine. So what it should be? B. And magnesium, it evolves hydrogen gas from dilute acids. Why? Because magnesium is present above hydrogen in the reactivity series. Let's take up the next question. Metals form what type of oxides? Basic and amphoteric. Non-metals form what type of oxides? Acidic and neutral. Okay, so this is matched here only. This is B, this is A. Sometimes very simple questions are also asked. Like lead. Lead is a metal. Silicon is a non-metal. Okay, so this is the way we can solve. Taking up the next one. The processes. Oxide ore, how it is concentrated? By or dressing of oxide ore, how it is done? Cross flotation is for sulfide ores, right? So we can write this third as D, because the ore particles are wetted by water and the gangue particles are wetted by, ore particles are wetted by oil and the gangue particles are wetted by water. So they settle down and the ore particles float on the surface. So sulfide ores by cross flotation. Whereas your oxide ore is by gravity separation. Do you remember what is gravity separation? The ore is kept in the flow of water, right? And what happens that the lighter gangue particles are washed away and the ore particles being heavier, they settle there only. Then in this case, we have got chromite. Chromite has got what? Iron. So this iron is what? Magnetic property it will show. So it can be separated by magnetic separation. And bauxite is by leaching. Here you must be wondering what is leaching. Now in this what happens that your bauxite, that is Al2O3, this is 2H2O. First of all, this is calcinated. Now students, after calcination, what is going to happen? So after calcination, what will happen? Water molecule will be released out and I'll get here Al2O3, that is porous ore. So this is Al2O3 is porous. Right? Now this Al2O3 contains impurities like SiO2 or iron oxide, which cannot be removed by your simple processes of separation. So this Al2O3 is treated with sodium hydroxide where it forms sodium aluminate, that is NaAlO2. This is sodium aluminate. Now in this case what happens students, that your ore, that is aluminium, reacts with sodium hydroxide and forms sodium aluminate and comes into solution, whereas your impurities like titanium oxide or iron oxide, they get settled down. And sodium aluminate can be obtained by filtration. So after filtration, this is kept for setting, right? A few crystals of aluminum hydroxide are added, and so that it gets precipitated as aluminum hydroxide. That is then heated and we get alumina, again Al2O3 without impurities. So this is leaching, or this is also called as chemical separation. Now let's take up our next question. It is rusting of iron. What is it? What is rusting? It is a formation of Fe2O3. That is hydrated Fe2O3. It's not simple oxide layer. It is hydrated Fe2O3. So from our options we can get that it is prevented by galvanization. That is B. Now this aluminium loses its shine on exposure to air by Because of the formation of dull layer of oxide, that is aluminium oxide. Now next is formation of green coating on the surface of copper is, it would be some copper. Okay, so it is copper carbonate and copper hydroxide, that is basic copper carbonate. And rusting of silver is due to the formation of silver sulfide. So these are the concepts actually. There is no logic behind it. Iron forms hydrated oxides, aluminium forms aluminium oxide, silver forms silver sulfide, copper forms basic copper carbonate. So you can't put any logic here. You have to remember this. That's it. Now let's move to our next question. Yeah, it is mercury is extracted from mercuric sulfide by. Now what is mercury? It is unreactive or it is very less reactive. So what happens? By roasting only you can obtain it. That is when you are heating mercury, it would be oxidized to form mercuric oxide. Then finally it would be reduced to mercury. So it is by roasting only. So we can write it here as C. Then alumina. Alumina cannot be reduced by carbon. Remember that. Because, now I'll put a note here. Alumina, that is Al2O3, cannot be reduced by carbon. Why? Because aluminium has more affinity for oxygen than carbon. And if at all we need to reduce it by carbon, a very high temperature is required. And to attain that high temperature, what will happen? The cost of the company will rise. So, what is done is, it is reduced by electrolytic reduction. Then finally, it is hematite or Fe2O3. So it can be reduced both by carbon as well as by aluminium. And what is this reaction called? Thermite reduction. That is Fe2O3 plus of aluminium. What all are the products obtained here? The products obtained are Al2O3 and what? Al2O3 plus Fe solid. How is, whether it is it solid? No, it is in molten state. That is, it is liquid, right? That is in molten state plus lots of heat. I think there is no need to write the state. It is molten iron is obtained. When you are writing heat, it means there is molten iron. So your hematite can be reduced by carbon as well as by aluminium. So now this concludes our problem solving session of metals and non-metals. I hope you enjoyed this session, and do practice lots of questions related to the reactivity series of metals as well as the reactivities of non-metals. Now don't think that it is just for 10. This is basic for your engineering entrance exam or medical entrance exam. So questions from this chapter are very important and they come in your entrances. So this topic, all the 10 topics for that matter are very important. They are the basics of chemistry of 11th and 12th. Okay. So thank you very much for listening patiently. We will be meeting in our next session with questions related to carbon and its compounds, and also first of all I'll have to cover its theory. So we will be meeting in our next session with the theory of carbon and its compounds. So children, do practice lots and lots of questions of metals and non-metals.